Hello everyone, thank you for signing in and watching my live stream. This is Algebra. Welcome to Algebra 2. This is lesson 1. I'm Mr. Matt and Dr. Tot is down there. He's fallen asleep. He'll probably wake up in a second. I wanted to talk today about just some number relationships in general to start us off, just naming greater than, less than values. And then the real heart of today's lesson is going to be on the properties of addition and multiplication in algebra. Namely, there are 6 that we need to go through, and those will thread throughout this course and be repeated again and again. So we're going to go through those in depth. But first, let me actually just share my screen with you. And so I want to start by just looking at a few numbers on a number line. So I'm going to give you 1 minute. I'd like you to graph the following values on a number line and then list the values in ascending order. So that means from least to greatest. So I'll give you 2 minutes. Okay, so in this set of values, we have 8, -7, 0, and -2. When we're trying to place values on a number line, we want to orient ourselves to the number 0. 0 is the only number that is neither positive nor negative. Any number to the right of 0 on the number line is going to be positive. Anything to the left of 0 on the number line is going to be negative. 0 happens to be one of our values now, so it's kind of 2 birds, 1 stone type of situation. So if we put 0 right in the middle of our number line, 8 is going to be to the right. -2 and -7 will be to the left. Remember that negative values are counterintuitive, meaning higher magnitudes mean lesser value. -7 is a smaller number than -2, right? Would you rather owe somebody $7 or owe them $2? -2 is a larger number than -7, even though the magnitude of -7 is larger than -2, right? Its absolute value is larger. It's farther from 0 on a number line, but it's farther from 0 in the wrong direction. It's more left than -2. So in ascending value, meaning least to greatest, then we would have -7, comma, -2, comma, 0, comma, 8. you have any questions, please let me know. Otherwise, let's take a look at this second problem. I'll give you 2 minutes. Okay, so in this set we have +4, -9, -3, and +9. So again, orient yourself on a number line relative to the value of 0. So if we put 0 in the middle here, then negative and +9 are the largest and smallest, -9 and +9 are the smallest and negative numbers respectively. So I'm going to put them all the way over here, -9 to the left of 0, +9 to the right of 0. -3 is going to be closer than -9 to 0. 4 will be closer to 0 than +9, though not as close to 0 as -3. Even though they're going the opposite directions, -3 is closer to 0 than +4. So in ascending value, we would in ascending order rather, we would have -9, -3, +4, +9. If you have any questions, just let me know. I'll give you 1 minute. Please look at number 3. Okay, in this set we have -5, -6, -2, and +2, so we only have one positive number. So this time I'm going to orient my 0 a little bit more to the right because I have so many negative numbers and not very many positive ones. I'm going to deal with positive 2 first because it's the only positive one, the only value to the right of 0. Then the next larger number in our set is negative 2 because it's the least negative number out of all the other values. Then we'd have negative 5, and then we'd have negative 6. So in ascending order from least to greatest, we would have negative 6, negative 5, negative 2, positive 2. If you have any questions, please let me know. Otherwise, let's look at 4. I'll give you 1 minute. Okay, so we have negative 7, 1, negative 4, and negative 1. Again, we only have one positive value, so I'm going to orient my number line skewed towards the negative. So I'm going to push the 0 rightward. My only positive value is 1, so I'm going to stick that right to the right of 1. Then I have negative 1, negative 4, and negative 7. So in ascending order, I'd have negative 7, negative 4, negative 1, positive 1. Again, any questions? If you have any questions, please let me know. Let's look at 5. Now a hint for 5, all of these guys have different denominators. So to be absolutely sure, you might want to first convert into a common denominator, then compare the numerators directly. I'll give you 2 minutes. Okay, so looking at all of these fractions, we have positive 2/3, positive 3/2, positive 4/3, positive 5/2. Now, two of them, we have two pairs that have common denominators, but they don't all have the same denominator. Notice that the common multiple between 3 and 2 is 6. So I'm going to go ahead and convert all of these guys to a common denominator. So I have 2/3. I want a denominator of 6, not a denominator of 2. So I'm going to multiply this denominator by 2. But if I do it to the denominator, I have to do it to the numerator. Remember the golden rule in mathematics. If you do it to one side, you got to do it to the other side. You can do almost anything you want as long as you do the same to the left as you do to the right, the same to the top as you do to the bottom. So if we multiply the denominator by 3, we have to by 2. We have to multiply the numerator by 2. So the numerator is going to be 2 times 2 is 4, 3 times 2 is 6. So 2/3 written as with a denominator of 6 would be equivalent to 4/6. 3/2, I'd have to multiply 2 by 3 to get 6. So I'm going to multiply the numerator by 3, and I'm going to get 9/6. For 4/3, to go from 3 to 6, I need to multiply by 2. So I'm going to multiply the numerator by 2 as well, and this will turn into 8/6. And then I have 5/2. To go from 2 to 6, I need to multiply by 3. So if I multiply the denominator by 3, I must multiply the numerator by 3. And so this guy is going to be 15/6. Now we have all positive terms, so I'm going to orient my number line skewed towards the positive value. So I'm going to push my 0 all the way over here. Now they all have the same denominator, so you can compare the numerators directly. The smallest numerator is 4. That's in the value of 2/3. So 2/3 is the smallest. Then we have the next smallest numerator is 9. That belongs to the fraction 3/2. Then we have the numerator of 8. That belongs to the fraction of 4/3. And then finally we have 15/6, which relates to 5/2. And if you take a calculator and you evaluate these terms, then you'll find that 2/3 is 0.67, 3/2 is 1.5, 4/3 is going to be 1.33, and 5/2 is going to be 2.5. So you can see they definitely are in the correct order, because 0.67 is less than 1.5, which is less than 1.3. Oh, excuse me. What happened here? Oh, I mixed them up. 9 is definitely larger than 8. My apologies. Good thing I checked. So let's correct that. Oops. 8/9 is smaller than 8/6 is smaller than 9/6. So this guy should be 4/3, and then this guy should be 3/2. My apologies there, I overlooked that numerator. So this guy should be 1.33. This guy should be 1.5, which is less than 2.5. So listed in ascending order, this is your answer right here. If there are any questions, please let me know. Otherwise, I'll give you 1 minute. Please look at number 6, and then we're going to move on to the properties of addition and multiplication. Okay, so looking at these values, we have -2, -3/2, -1, and -1/2. Notice we have common denominators here for the first two, but we can go ahead and write the other two values. -2, we can write the other two values with the denominator of 2 is what I meant to say. Notice we can write -2 as a fraction by just -2/1. You can write any value as a fraction by just putting it over 1. To go from a denominator of 1 to a denominator of 2, I need to multiply by 2. So if I do it to the denominator, I have to multiply the numerator by the same value. -2 times 2 is going to be a -4. 1 times 2 is going to be 2. I can do the same thing with -1. I'm going to write -1 as a fraction by putting it over 1. To go from 1 to 2, I need to multiply by 2. So if I do that, if I multiply by 2 in the denominator, I need to multiply by 2 in the numerator. -1 times 2 is going to be -2. 1 times 2 is 2. So you can think about this as -4/2, and you can think about this guy as -2/2. Just a short digression here. I just want to point out the validity of this process. Notice, what is 2/2? What is anything divided by itself? 1, right? And anything times 1 is that same something. So you see, I'm manipulating the values in the numerator and the denominator, but I'm not changing the relationship between the numerator and denominator. So that's why this is a valid mathematical process. It's not changing the number. It's just manipulating the numerator and denominator, but it will evaluate to the same exact number. And it must evaluate to the same exact number, otherwise it wouldn't be valid. So I just wanted to explain that. So ordering these in ascending order, least would be -4/2, followed by -3/2, followed by -2/2, followed by -1/2. So that was actually the order that they came in. So -2, -3/2, -1, and -1/2. Okay, if there are any questions, please let me know. Otherwise, I'd like to go through the real crux of this lesson, so like the main point, the essential portion. And I want to take a look at the properties of addition and multiplication. And so there are a few properties that will come up again and again in mathematics, and we're going to go through them right now. So each one of these, except for the last, has its own application to addition and multiplication. Okay, so there are two rules for each property, except for the last property, which involves both addition and multiplication in of itself. Okay, so the first property is called the closure property. And this serves as the basis, the definitional basis for the other properties. This property basically says that whenever we are adding two values together or multiplying those two values together, we are assuming that those values and the resulting values are real values. Now, what are real values? So we think that all numbers are real numbers. What's an unreal number, right? Well, there actually are non-real numbers. They're called imaginary numbers is one set of non-real values. And they exist on an imaginary axis, but they do so because they violate a rule of mathematics, namely taking the square root of -1. And so mathematicians factor out that negativity underneath the radical and express it in terms of an imaginary value. That might seem like a whole lot of nothing, or it doesn't really make sense, because if they're not real values, you might be asking what's the use of having them. They actually might turn into real values through mathematical processes, so you can actually obtain real outputs from non-real inputs. I know that sounds counterintuitive, but it's true. But what you need to know is that this just stands as a definitional basis that we are dealing in real numbers. So the properties for addition, the closure property for addition is A plus B is a real number. And this is the only property which comes in the form of a sentence. Everything else is much more mathy, or more mathematical statements. I should say are mathematical statements, not sentences. But again, these are foundational definitions. The closure property of multiplication says basically the same thing, but now we're multiplying. A times B is a real number. So this property is pretty much a dead giveaway if you're asked to identify addition and multiplication properties on a test, because it's the only one that's going to come in the form of a sentence. The other ones are going to be expressions or equations. So the second property, that's the closure property of addition and multiplication. The second property is the commutative property. And what the commutative property says basically is with addition and multiplication, order does not matter. Order has no effect on addition or multiplication. 2 plus 3 is 5. 3 plus 2 is 5. 3 times 2 is 6. 2 times 3 is 6. So you can see that the order in addition and multiplication doesn't actually matter at all. So the actual rule here, so for addition, the property is A plus B is equal to B plus A. For multiplication, A times B is always equal to B times A. Next, we have the associative property. And the associative property basically says that grouping does not matter with addition and multiplication. So for addition, the associative property is that if we group A plus B plus the quantity C, that is always equivalent to A plus the quantity B plus C. So it doesn't matter in which grouping, in which method or manner that you group the values. If you're adding them all up, then they're equivalent expressions. For multiplication, we could say A times the quantity B times C must be equal to A times B quantity times C. So it doesn't matter which order you state them in, which way you put the parentheses, these will be equivalent statements no matter what. If you have any questions, please let me know. Next, we have the identity property. Oops. And this basically tells us what makes an expression in addition or multiplication unchanged. So with addition, the magic value, the magic unchanging value is 0. So the identity property for addition is that A plus 0 must always equal A. And we could switch that around because we know that addition is commutative. So 0 plus A has to be equal to A. With multiplication, the magic unchanging value is not 0, it's 1. So A times 1 has to be equal to A. And inversely, 1 times A must always equal A. Fifth property is the inverse property. And this is almost the converse of the identity property. So this is what value would we have to add in order to make the value 0. So for example, addition, the inverse property of addition says that A plus negative A must always equal 0. For multiplication, the inverse property is A times 1 over A will always be equal to 1. So those first 5 properties had separate applications for addition and multiplication. This last property deals with both, and this is the distributive property. And this only has one rule because it actually has multiplication and division in it, multiplication and addition in it. And the distributive property says that A times some quantity B plus C is the same thing as A times B plus A times C. So you can take that beginning value and you can distribute or share or apply it within the parentheses. Okay, if there are any questions, please let me know. Otherwise, let's take a look at some problems. So I'd like you to identify the property that's being expressed. So I'll give you 2 minutes. Please look at 1 and 2. Okay, so if we look at the first one, first of all, you can always identify from the operation whether it's the addition or multiplication correlative, um, or I should say corollary. So corollary is a version of a formula. So for the first one, we can see that the operation is multiplication. The second one, the operation there is addition. The first one is saying that 3 times 2 is the same thing as 2 times 3. In other words, it's saying that order doesn't matter. So this is the commutative property of multiplication. The second one is saying 6 plus 0 is equal to 6. First of all, we have an operation of addition. So clearly it's some property of addition. Second, it's saying what remains unchanged. What value added to this number would make it unchanged. So this is the identity property of addition. If there are any questions, please let me know. Otherwise, I'd like you to identify which property is being used in numbers 3 and 4. I'll give you 2 minutes. So let's first understand what operations are occurring in each of the mathematical statements. So in number 3, we have 8 times 1/8. So that's obviously multiplication. In the fourth, we have 1 plus 3 is a real number. So the first, number 3 is the inverse property of multiplication. And number 4 is the closure property of addition. As always, if you have any questions, then please let me know. Otherwise, let's look at 5, and 6. I'll give you 2 minutes. And this will bring us up to the end of class today. We'll pick back up on Wednesday. with further examples. Okay, so number 5 says 5 times the quantity or group 3 times 4 is equal to the quantity or group 5 times 3 quantity times 4. So we have multiplication as an operation, so it's some property of multiplication, and then it's telling us that grouping doesn't make a difference. So this is the associative property of multiplication. For number 6, we have 1 plus 4 is equal to 4 plus 1. So we're adding here, so this is some property of addition, and it's saying us that the order doesn't make a difference. So this is the commutative property of addition. Okay, so that brings us up to the end of class today. Let me bring my screen back up to, well, my camera back up to full size. So thank you guys very much for signing in and watching my stream. If you found this to be helpful, please like, favorite, and subscribe. I'm here for you guys every day, starting at 3 o'clock with the SAT prep program. And then we alternate Monday, Wednesdays, Fridays. Monday, Wednesdays, and Fridays are math days. So pre-algebra, algebra 1, geometry, algebra 2. Tuesdays are reading days. So we have clusters of grades 9, 10, then cluster 10, 11, 12, then AP Lang, and then AP Lit. And on Thursday is our grammar and punctuation day in the same ordination or categories as the reading days. So we're going to be clustering the grades 9 and 10 after the SAT class, then 11, 12, then AP Lang and AP Lit. I want to also let everybody know that you don't have to be in any of those classes to watch my lessons. They're going to build on each other, and especially the language classes. I'm going to try and cover as much as I can the same topics in each of the different grade levels, but just at different reading, using different passages or different difficulty resources. So it would be, if you're struggling in any of these topics, it would be really useful to start at one of the lower levels and then work your way up through the day, and you can always watch them as recordings. So thank you guys very much, and I will see you all on Wednesday. Have a wonderful night.